Hello there, and welcome to Whispers of Science, where wonder takes its time and knowledge unfolds like a gentle conversation by candlelight. Tonight, we're embarking on a quiet journey to one of nature's most breathtaking phenomena, the Aurora Borealis, those dancing curtains of light that paint the northern skies in colors that seem almost too beautiful to be real. I'm so glad you found your way here. Whether you're settling into bed, curling up with a warm drink, or simply seeking a peaceful moment away from the noise of the world, this is your invitation to slow down, breathe deeply, and let curiosity carry you somewhere magical before we begin our gentle exploration. I'd love to know where in the world you're listening from tonight. And have you ever been fortunate enough to witness the northern lights with your own eyes? There's something rather fitting about discussing these celestial light shows as we're scattered across different time zones, each of us experiencing our own slice of darkness and light. If you find this soft science journey soothing or perhaps just wonderfully distracting from the day's worries, I'd be ever so grateful if you gave the video a like and maybe subscribed it. Helps this little corner of calm reach others who might need a moment of quiet fascination too. Now, I do hope this isn't so captivating that it keeps you awake, but if it does well, at least you'll drift off with visions of shimmering green curtains dancing through your dreams. So settle in and I'll let your shoulders relax and let's begin, because somewhere between solar winds and magnetic fields, between ancient myths and modern understanding, lies the story of why our sky sometimes decides to glow. Picture this. You're standing in the middle of nowhere on a crisp, clear night in northern Canada, or perhaps Finland or Alaska. The air is so cold it seems to crystallize around you, and the silence is so complete you can hear your own heartbeat. Then slowly, almost imperceptibly, a faint green glow begins to emerge on the horizon. At first, you might think your eyes are playing tricks on you, but then the glow strengthens, spreads, and suddenly the entire sky above you erupts into ribbons of light, dancing and swirling in colors that seem to defy explanation. Emerald green, the most common hue, but sometimes deep purple, brilliant pink, or even rare touches of blue and yellow. For thousands of years, humans have looked up at these mysterious lights with a mixture of awe, fear, and wonder. The Inuit peoples of the Arctic had dozens of names for the aurora, believing them to be the spirits of the dead playing with a walrus skull across the heavens. In Norse mythology, they were the reflections of light bouncing off the shields and armor of the Valkyries as they rode across the sky. The very name Aurora Borealis comes to us from the brilliant mind of Galileo Galilei, who combined Aurora, the Roman goddess of dawn, with Boreas, the Greek god of the north wind. Even this great scientist, with all his revolutionary insights into the cosmos, could only describe what he saw, not explain why it happened. For centuries, the aurora remained one of nature's most beautiful mysteries. Travelers would journey to the far north, hoping for just a glimpse of these celestial dancers. Artists would attempt to capture their ethereal beauty on canvas, though none could quite convey the living, breathing quality of the lights themselves. But what exactly causes this magnificent display that has inspired countless myths, legends, and late night pilgrimages to the world's most remote locations? The answer begins not here on Earth, but 93 million miles away in the roiling surface of our sun. The sun you see is not the gentle, steady beacon it appears to be from our earthly perspective. It's actually a massive nuclear furnace, constantly churning with violent magnetic storms and explosive eruptions. Every second of every day, our star converts millions of tons of hydrogen into helium, releasing tremendous amounts of energy in the process. This energy doesn't just travel to us as light and heat, it also comes in the form of what scientists call the solar wind, a continuous stream of charged particles, protons, and electrons that race through space at speeds of up to 1 million miles per hour. Imagine, if you will, an invisible river of electrically charged particles flowing from the sun in all directions, carrying with it the sun's magnetic field. Now, our planet Earth has its own magnetic field generated deep within its molten core. This magnetic field acts like a protective shield, deflecting most of the solar wind away from our atmosphere, much like water flowing around a rock in a stream. Without this magnetic shield, life as we know it simply couldn't exist. The solar wind would strip away our atmosphere, leaving us as barren as Mars. But here's where things get interesting. Our planet's magnetic field isn't perfectly spherical. It's more like a teardrop with the blunt end facing the sun and a long tail streaming away on the night side. This shape is created by the constant pressure of the solar wind pushing against our magnetic boundaries. Most of the time, this system works beautifully. The solar wind flows around our magnetic field and continues on into deep space, harmlessly. But occasionally, something more dramatic happens. The sun becomes more active, launching what's called a coronal mass ejection, a massive bubble of solar material and magnetic field that races toward Earth at incredible speeds. When one of these solar storms reaches our planet, it can temporarily overwhelm our magnetic defenses. The charged particles find their way into our upper atmosphere, following the invisible magnetic field lines that converge at our planet's magnetic poles. This is why auroras are most commonly seen in the far north and far south, in regions scientists call the auroral ovals. But what happens when these charged particles actually enter our atmosphere? Why do they create light? And why those specific colors? The answer lies in the very atoms that make up the thin air high above our heads. Our atmosphere is composed primarily of nitrogen and oxygen molecules, and when the charged particles from the sun collide with these molecules at altitudes of 60 to 400 miles above the Earth's surface, something beautiful happens. The collision excites the electrons in these atmospheric particles, causing them to jump to higher energy levels. But nature abhors instability, and these excited electrons quickly fall back to their normal energy states. When they do, they release the excess energy as photons, particles of light, and the color of that light depends entirely on which type of molecule was struck and at what altitude. Oxygen molecules, when struck at high altitudes around 200 miles up, produce that classic auroral green, the color most people associate with the northern lights. It's the same green you might see if you could peer into the heart of an emerald, but oxygen at even higher altitudes, around 300 miles up, glows red, though this red light is often too faint for the naked eye to detect. Nitrogen contributes the purples and blues that sometimes dance alongside the greens. When nitrogen molecules are excited, they can produce a beautiful blue light, or sometimes a deep purple that seems to pulse and shimmer with an almost liquid quality. The altitude matters tremendously because the atmosphere becomes thinner the higher you go at 60 miles up. Where the atmosphere is still relatively dense, Collisions happen frequently, and the light tends to be more diffuse at 200 miles up where the air is much thinner. The light appears more concentrated and defined, creating those sharp ribbons and curtains that make aurora photography so spectacular. But the aurora isn't just about individual atoms and molecules glowing. It's about the dynamic interaction between our planet's magnetic field and the solar wind. The shape and movement of the aurora reflects the invisible architecture of magnetic field lines stretching from pole to pole when solar activity is low. The aurora appears as a relatively stable arc across the northern horizon, but when a major solar storm strikes Earth, the aurora can explode into action, covering vast areas of the sky with writhing columns of light that seem to dance with a life of their own. These dancing movements aren't random, they follow the constantly shifting patterns of our planet's magnetic field as the solar wind pressure changes, as our planet rotates, as the sun's own magnetic field fluctuations reach us. The aurora responds like a vast atmospheric instrument playing a silent symphony of light. The intensity of an aurora is measured on something called the KP index, ranging from 0 for very quiet conditions to 9 for extreme geomagnetic storms. During major solar events, the aurora can be seen much farther south than usual, occasionally reaching as far as Northern California or even the Mediterranean. But there's something almost mystical about experiencing the aurora in its natural habitat in the deep Arctic where the air is crystal clear. The nights are long and dark, and the silence is so profound that some people claim they can actually hear the aurora, a soft crackling or whooshing sound, though scientists debate whether this is real or psychological. Indigenous peoples of the Arctic have observed the aurora for thousands of generations, and their traditional knowledge often contains insights that complement modern scientific understanding. They've noted patterns in aurora activity, connections to weather and animal behavior, and subtle variations in color and movement that Western science is only beginning to appreciate. The aurora also plays a role in our planet's larger electromagnetic environment during major geomagnetic storms. The same processes that create beautiful auroras can also disrupt radio communications, interfere with satellite operations, and even cause power grid failures. The beauty and the potential for disruption are two sides of the same cosmic coin. What's particularly fascinating is how the aurora varies throughout the year and even throughout the night. The best viewing typically occurs during the equinoxes in March and September, when Earth's magnetic field is tilted at just the right angle relative to the solar wind. This creates a kind of celestial alignment that makes the aurora more frequent and more intense. During the long polar night from October through March, the darkness provides the perfect canvas for the aurora's artistry. But even within a single night, the display changes dramatically. Often the evening begins quietly, with perhaps just a faint green glow on the northern horizon. Then, as the night deepens, the show intensifies. Ribbons of light begin to undulate across the sky, sometimes moving so quickly you can actually see them shift and dance in real time. The aurora has its own rhythm, its own breathing pattern. Sometimes it pulses gently like a slow heartbeat. Other times, it flickers rapidly like candle flames in a breeze. Occasionally, it explodes into what scientists call a substorm, a dramatic brightening that can fill the entire sky with writhing columns of light that seem to reach down from the heavens toward the Earth below. Photographers who specialize in capturing the aurora have learned to read these patterns. They know that certain cloud formations on the horizon might indicate approaching geomagnetic activity. They watch for the telltale brightening of stars that suggest the atmosphere is becoming more transparent. They listen to space weather forecasts with the same attention that sailors pay to maritime conditions. But even with all our modern understanding and prediction capabilities, the aurora remains delightfully unpredictable. You might travel thousands of miles to the Arctic Circle during peak aurora season, only to be greeted by cloudy skies and quiet magnetic conditions. Conversely, you might step outside your door on an ordinary Tuesday evening and find the sky ablaze with unexpected celestial fire. This unpredictability is part of what makes aurora chasing so addictive. There's something profoundly humbling about standing beneath a display that reminds you how small you are in the context of the vast electromagnetic forces that govern our solar system. The aurora connects you viscerally to the sun, to the Earth's magnetic field, to the very atoms in the atmosphere above your head. Modern technology has revealed aspects of the aurora that were invisible to previous generations. Satellite imagery shows us the complete auroral oval as it encircles both magnetic poles simultaneously. We can see how the aurora responds in real time to changes in solar wind conditions, how it brightens and dims contracts, and expands like a living, breathing entity space, weather monitoring stations around the world now track the aurora's behavior with the same precision that meteorologists track hurricanes. We have early warning systems that can predict when a major geomagnetic storm is heading our way, giving us time to prepare both for the spectacular light show and for any potential disruptions to our technological infrastructure. Yet, for all our scientific instruments and mathematical models, there's still something ineffable about the aurora, something that can't be fully captured in equations or satellite images. Perhaps it's the way the light seems to move with purpose, as if it's trying to communicate something beyond human understanding. Perhaps it's the silence that accompanies the display, broken only by the soft whisper of wind across snow. Many people who witness their first aurora report a profound emotional response that catches them completely off guard. They expect to see something pretty, something worth photographing, but they don't expect to be moved to tears by the sheer otherworldly beauty of the experience. There's something about the aurora that speaks to a deeper part of human consciousness that connects us to our ancestors who looked up at the same phenomenon with wonder and reverence. The colors themselves seem to possess an almost supernatural quality that defies normal description. Photographers often struggle to capture the true appearance of the aurora because cameras see light differently than human eyes do. The green that appears so vivid to the naked eye might look pale and washed out in a photograph, while subtle reds and purples that the eye barely detects can blaze brilliantly on camera. This discrepancy between perception and recording has led to ongoing debates about what constitutes an authentic aurora photograph. Some purists insist that images should reflect exactly what the human eye would see, while others argue that camera sensors can reveal hidden aspects of the aurora that are no less real for being invisible to unassisted vision. The aurora also varies dramatically depending on your location within the auroral zone. In northern Alaska, the aurora often appears directly overhead, creating a dome of light that surrounds you completely in northern Scandinavia. It might appear as distant curtains dancing along the northern horizon in Churchill, Manitoba. It often takes the form of distinct rays shooting upward from the earth, like searchlights piercing the darkness. Each location has its own aurora personality, shaped by local magnetic field variations, atmospheric conditions, and geographic features. The aurora over the Canadian prairies tends to be broad and sweeping, while the aurora over Norwegian fjords often appears more concentrated and intense, reflected in the dark waters below like a mirror image of celestial fire. Indigenous communities throughout the circumpolar north have developed sophisticated systems for predicting and interpreting aurora activity. The Sami people of northern Scandinavia traditionally used aurora observations to make decisions about reindeer herding patterns. Inuit elders in Greenland could predict weather changes based on subtle variations in aurora color and movement. These traditional knowledge systems represent thousands of years of careful observation passed down through generations of people whose lives depended on understanding the subtle signs and patterns of their Arctic environment. Modern scientists are increasingly recognizing the value of this traditional knowledge and working to incorporate it into contemporary research. The aurora also plays a crucial role in upper atmospheric chemistry. The same energetic collisions that create the beautiful light displays also trigger complex chemical reactions that affect the composition of the atmosphere at high altitudes. These reactions can influence everything from ozone concentrations to the formation of unusual cloud types that exist only in the polar regions. During major geomagnetic storms, the aurora can deposit significant amounts of energy into the upper atmosphere, causing it to heat up and expand. This expansion can actually affect the orbits of low Earth satellites, creating drag that gradually pulls them toward Earth more quickly than expected. The International Space Station regularly adjusts its orbit to compensate for this aurora induced atmospheric heating. The connection between the aurora and space weather extends far beyond Earth. Our solar system's other planets also experience auroral displays, though they look quite different from our familiar green curtains. Jupiter's aurora is powered by its own magnetic field, interacting with charged particles from its volcanic moon. Io Saturn's aurora appears as a delicate ring around its magnetic pole, influenced by its complex system of rings and moons. Even Mars, with its weak magnetic field, experiences a kind of aurora, though it's much fainter and more diffuse than Earth's spectacular displays. Studying these planetary auroras helps scientists understand the fundamental physics of how magnetic fields interact with charged particle streams throughout the universe. The Aurora Borealis also serves as a natural laboratory for understanding plasma physics, the fourth state of matter that makes up most of the visible universe. When charged particles from the solar wind interact with Earth's magnetic field and atmosphere, they create what scientists call a plasma environment, where electrons and ions behave according to complex electromagnetic principles. This plasma physics research has practical applications far beyond aurora science. It helps us understand how to create controlled nuclear fusion reactions, how to design better spacecraft propulsion systems, and how to protect astronauts from radiation during long-duration space missions. The dancing lights above our heads are teaching us fundamental lessons about the universe itself. But perhaps one of the most remarkable aspects of the aurora is how it connects us to the deep rhythms of our solar system. The 11-year solar cycle creates predictable patterns of aurora activity, with peak displays occurring during solar maximum when the sun's magnetic field is most active and chaotic. During solar minimum, aurora activity drops to relatively quiet levels, appearing mainly as faint arcs near the magnetic poles. But as the solar cycle builds toward maximum, the aurora becomes more frequent, more intense, and visible at lower latitudes. This cosmic clockwork has been ticking for billions of years, long before humans ever looked up at the sky in wonder. The timing of these solar cycles has influenced human history in ways we're only beginning to understand. The Maunder minimum, a period of unusually low solar activity from 1645 to 1715, coincided with the Little Ice Age in Europe. During this time, auroras were extremely rare, leading some historians to suggest that the lack of geomagnetic activity may have contributed to climate changes that affected agriculture and society. Modern climate scientists are still debating the connections between solar activity, aurora frequency, and Earth's climate systems. While the aurora itself doesn't directly influence weather patterns, the same solar variations that control aurora intensity also affect the amount of energy Earth receives from the sun. These subtle changes can accumulate over decades to influence long term climate trends. The aurora also provides a unique window into the health of our planet's magnetic field, which has been weakening gradually over the past few centuries. Some scientists worry that Earth's magnetic field might be preparing to flip, with the north and south magnetic poles exchanging positions. This has happened many times throughout Earth's geological history, but never during recorded human civilization. If such a magnetic reversal were to occur, the aurora patterns would change dramatically. The familiar northern and southern lights might disappear temporarily or appear in completely different locations around the globe during the transition period. When our magnetic field is weakest, we would also be more vulnerable to harmful solar radiation, making aurora research crucial for understanding our planet's future. Indigenous Arctic peoples have oral traditions that describe unusual aurora displays and changes in aurora patterns over many generations. These stories sometimes describe periods when the aurora disappeared entirely or appeared in strange colors and locations. While we can't know for certain, these oral histories might preserve memories of past geomagnetic events that occurred before written records began. The aurora has also influenced human culture in unexpected ways. The ethereal beauty of the northern lights has inspired countless works of art. Literature and music composers have written symphonies that attempt to capture the aurora's flowing movements. Painters have struggled to convey its otherworldly colors, and poets have searched for words adequate to describe its sublime beauty. In recent decades, aurora tourism has become a significant economic force in northern communities. Cities like Fairbanks, Alaska, Yellowknife, Canada, and Tromsø, Norway, have built entire industries around aurora, viewing complete with specialized hotels, tours, and photography workshops. Visitors travel from around the world, willing to brave frigid temperatures and long, dark nights for the chance to witness this natural phenomenon. The rise of social media has amplified interest in the aurora, as spectacular photographs and time lapse videos circulate globally, inspiring ever more people to add aurora viewing to their bucket lists. This democratization of aurora imagery has also led to better scientific understanding, as citizen scientists contribute observations and photographs that help researchers track aurora patterns and behavior. Aurora photography itself has evolved into a sophisticated art form, requiring not just technical skill, but deep understanding of aurora behavior, weather patterns, and optimal viewing conditions. The best aurora photographers combine scientific knowledge with artistic vision, patiently waiting in remote locations for the perfect combination of clear skies, active aurora, and compelling foreground elements. But beyond the cameras and the tourism and the scientific instruments, the aurora remains fundamentally a reminder of our planet's place in the larger cosmic dance. Earth is not an isolated world floating alone in space, but an active participant in the complex electromagnetic environment of our solar system. The aurora makes visible the invisible connections between our world and the sun. Every aurora display represents a moment when the boundary between Earth and space becomes permeable, when particles that began their journey in the nuclear furnace of the sun finally complete their 93 million mile voyage by painting light across our sky. In that sense, every aurora is a message from our star, written in the language of glowing atoms and dancing magnetic fields. The aurora also teaches us about the delicate balance that makes life possible on Earth. Our magnetic field must be strong enough to deflect most solar radiation, but not so strong that it completely blocks the interactions that create the aurora. Our atmosphere must be thick enough to protect us from space radiation, but thin enough at high altitudes to allow the aurora forming collisions to occur. This Goldilocks zone of conditions, not too much, not too little, but just right, extends far beyond the aurora to encompass all the factors that make Earth habitable. The aurora serves as a visible reminder of how precisely tuned our planet's systems must be to support the rich diversity of life we see around us. Scientists studying the aurora are also learning about the possibility of life elsewhere in the universe. Planets with strong magnetic fields and substantial atmospheres might experience their own versions of aurora displays, and these electromagnetic environments could be crucial for protecting any life that might evolve on those distant worlds. The search for exoplanets, planets orbiting other stars, has revealed thousands of worlds, but determining which ones might harbor life requires understanding complex interactions between stellar radiation, planetary magnetic fields, and atmospheric composition. The aurora research conducted here on Earth provides a template for understanding these processes on planets we may never visit as our technology advances. We're discovering new aspects of the aurora that previous generations could never have imagined. Radio telescopes can detect the electromagnetic signatures of aurora activity, revealing details invisible to optical observations. Spacecraft flying through the aurora can measure the energy and composition of the particles that create the light, providing ground truth for theoretical models. The aurora also varies on timescales from seconds to centuries. Rapid flickering occurs as turbulence in the solar wind creates momentary fluctuations in particle flow. Seasonal variations reflect Earth's changing orientation relative to the sun, and long-term changes track the waxing and waning of solar magnetic activity across multiple solar cycles. Understanding these multiple timescales requires combining many different types of observations: ground-based cameras and magnetometers, provide continuous monitoring of local aurora conditions. Weather balloons carry instruments into the aurora zone itself. Satellites observe the aurora from above, while space based telescopes monitor solar activity that drives the entire system. The future of aurora research promises even more sophisticated understanding as artificial intelligence helps scientists analyze vast amounts of aurora data, looking for subtle patterns that human observers might miss. Machine learning algorithms can process thousands of aurora photographs, identifying relationships between solar conditions, magnetic field variations, and aurora characteristics. But for all our advancing technology and deepening scientific understanding, the aurora retains its power to inspire wonder in anyone who witnesses it. There's something profoundly moving about standing beneath a display of lights that connects you directly to the cosmic forces that shape our solar system. The aurora reminds us that we live on a dynamic planet in a dynamic solar system where invisible forces constantly interact to create visible beauty. It's a nightly reminder that the universe is far more complex and interconnected than our daily experience might suggest, and it offers a glimpse of the elegant physics that govern everything from the smallest atomic interactions to the largest galactic structures as you drift off to sleep tonight. Perhaps you'll carry with you images of those dancing lights painting colors across the polar skies. Remember that somewhere above the Arctic Circle, the aurora may be performing its ancient dance, following magnetic field lines that stretch from pole to pole, responding to solar winds that left the sun days ago. And perhaps in your dreams, you'll find yourself standing in that crystalline Arctic air, watching ribbons of green and purple light flowing across the star filled sky, feeling connected to the vast cosmic ballet that surrounds our small blue planet every moment of every day, whether we can see it or not. The aurora also carries with it whispers of ancient wisdom, encoded in the very atoms that dance hundreds of miles above our heads. Each photon of light that reaches your eyes began its journey not just at the sun, but in the hearts of dying stars billions of years ago. The oxygen that glows green in the aurora, the nitrogen that shimmers purple, these elements were forged in stellar furnaces and scattered across the galaxy long before our solar system even existed. When you watch the aurora, you're witnessing a cosmic recycling program of unimaginable scale. The same carbon atoms that form your body, the same iron flowing through your blood, were once part of stars that lived and died in the deep past. Now they participate in this celestial light show, connecting you to the universe in ways that go far beyond mere observation. There's something rather poetic about how the aurora forms its colors, too. The green light that dominates most displays occurs at a very specific wavelength, 557.7 nanometers. To be precise, this isn't random. It's the exact frequency that oxygen atoms prefer when they're excited by just the right amount of energy. Too little energy, and nothing happens too much, and you get different colors entirely. It's like each type of atom has its own favorite song, its own preferred note in the cosmic symphony when solar particles strike with just the right energy. The atoms sing their signature tune in perfect harmony, creating those flowing ribbons of light that seem to dance to music. Only they can hear. The timing of these atomic performances is equally fascinating when an oxygen atom gets struck by a solar particle. It doesn't immediately release its light. Instead, it holds onto that extra energy for about 3/4 of a second before finally letting go. This brief delay might not seem like much, but when millions of atoms are doing this in sequence, it creates the flowing wave like motion that makes the aurora appear to ripple and undulate across the sky. Nitrogen atoms are even more particular about their performance. They prefer to work in pairs, creating molecular nitrogen that can produce either blue light or red light, depending on how much energy they receive. It's like having a musical duet where the harmony changes based on how loudly you're singing. But the aurora isn't just about individual atoms performing solo pieces. It's about vast atmospheric orchestras playing together in perfect synchronization. The magnetic field lines that guide the charged particles act like a conductor's baton, organizing the chaos of space weather into coherent patterns of light and movement. These magnetic field lines are invisible to us, but they're as real and structured as the steel framework of a skyscraper. They stretch from the north magnetic pole to the south magnetic pole, creating a three-dimensional cage around our planet. The aurora follows these invisible highways, painting their paths in light and revealing the hidden architecture of Earth's magnetic environment. During quiet periods, the aurora tends to follow these magnetic highways in predictable patterns, forming what scientists call the auroral oval, a ring of light that encircles each magnetic pole like a glowing crown. But when space weather becomes turbulent, these orderly patterns can explode into chaos, with aurora appearing far from their usual haunts, painting skies that haven't seen such displays in decades. The speed at which aurora can change is truly remarkable. Time-lapse photography reveals movements that happen too quickly for the human eye to follow. Curtains of light that seem solid and permanent can suddenly twist into spirals or break apart into fragments that race across the sky at hundreds of miles per hour. This rapid movement reflects the dynamic nature of the processes creating the aurora. The solar wind isn't steady like a gentle breeze. It's turbulent and gusty, filled with eddies and currents that change from moment to moment. When these fluctuations reach Earth's magnetic field, they create corresponding changes in the aurora like ripples spreading across a pond. But perhaps the most remarkable aspect of aurora movement is how it can seem almost alive. Almost intelligent observers often report the sensation that the aurora is watching them, that it responds to their presence or their thoughts. While this is certainly imagination, the aurora does respond to subtle changes in the electromagnetic environment that we can't consciously perceive. Your own body generates a weak magnetic field. Your nervous system operates on electrical impulses that create tiny electromagnetic signatures, while these are far too weak to influence the aurora directly. There's something symbolically beautiful about the idea that you and the aurora are both electromagnetic beings sharing the same space beneath the same magnetic field. The aurora also teaches us about the interconnectedness of seemingly separate phenomena. The same magnetic field that protects us from harmful solar radiation also channels that radiation into the polar regions, where it creates the aurora. The same solar activity that can disrupt our technology also provides us with some of nature's most spectacular entertainment. This duality runs throughout aurora science. What appears chaotic and random often reveals underlying patterns and structures. What seems purely beautiful also serves important scientific and practical purposes. The aurora is simultaneously art and science mystery and mechanism poetry, written in the language of physics. Indigenous peoples of the Arctic understood this duality long before modern science had words for it. Their stories and traditions treat the aurora not as a separate phenomenon, but as part of the larger web of relationships that connect Earth's animals and humans. The aurora influences animal behavior, which affects hunting patterns, which shapes human culture, which creates stories that help people understand their place in the cosmos. Modern research is rediscovering some of these connections, finding that aurora activity does indeed correlate with changes in animal behavior, migration patterns, and even plant growth cycles in the far north. The electromagnetic fields associated with major aurora displays can affect the navigation systems of migrating birds and the feeding patterns of marine mammals. There's also growing evidence that aurora activity might influence human behavior and health. Though the mechanisms aren't fully understood, some studies suggest that periods of intense geomagnetic activity correlate with changes in human sleep patterns, mood disorders, and even emergency room visits. Whether these connections are real or coincidental remains an active area of research. The aurora's influence on human consciousness might go deeper than mere physical effects. There's something about witnessing the aurora that seems to shift people's perspective on their place in the universe. Many aurora observers report profound spiritual or philosophical insights during their viewing experiences, as if the dancing lights had opened a door to deeper understanding. Perhaps this happens because the aurora makes visible the invisible forces that surround us constantly. We live our daily lives largely unaware of the electromagnetic fields that permeate everything. The charged particles streaming from the sun, the magnetic field lines threading through space. The aurora strips away this invisibility, revealing the hidden energies that connect everything in the cosmos. The colors themselves seem to bypass rational thought and speak directly to some deeper part of human consciousness. The particular shade of green that dominates aurora displays doesn't exist anywhere else in nature in quite the same way. It's neither the green of growing plants nor the green of ocean water, but something entirely unique, something that seems to come from another world entirely. This otherworldly quality has made the aurora a bridge between science and spirituality, between the measurable and the mysterious. Throughout history, people have used aurora observations as starting points for thinking about larger questions about existence, so consciousness, and humanity's relationship with the cosmos. Modern aurora researchers often find themselves grappling with similar questions as they delve deeper into the physics of the phenomenon. They discover that the aurora reveals not just the mechanics of particle interactions, but something more fundamental about the nature of energy matter and the strange quantum processes that govern reality at its deepest levels. Quantum mechanics plays a subtle but important role in aurora formation. The energy levels that determine which colors are emitted when atoms are excited. These are quantum mechanical properties that can only be understood through the strange mathematics of probability waves and electron orbitals. The aurora is, in a sense, quantum mechanics made visible. This connection between the aurora and quantum physics opens up fascinating possibilities as our understanding of quantum phenomena advances. We might discover new ways to influence or interact with aurora displays. Quantum sensors might detect subtle aspects of aurora behavior that current instruments and miss. Quantum communication systems might use aurora related phenomena to transmit information. The future of aurora science promises revelations we can barely imagine as artificial intelligence helps us process vast amounts of aurora data. We're beginning to see patterns that were invisible to human observers. Machine learning algorithms can analyze thousands of aurora photographs, simultaneously identifying subtle correlations between solar activity, magnetic field variations, and aurora characteristics. These computational approaches are revealing that the aurora is even more complex and structured than we previously realized. What appears to be random dancing light actually follows intricate rules and patterns that reflect the underlying physics of plasma dynamics, magnetic field interactions, and atmospheric chemistry. Citizen science is also playing an increasingly important role in aurora research. Smartphone apps allow aurora observers around the world to report their sightings in real time, creating a global network of aurora monitors that complements professional scientific instruments. This crowdsourced approach has already led to the discovery of new types of aurora phenomena that might have been missed by traditional monitoring systems. One particularly exciting development is the discovery of what researchers are calling Steve, a narrow ribbon of purple light that appears alongside traditional aurora displays. Steve was first identified by citizen scientists who noticed that their photographs showed unusual features that didn't match established aurora categories. Professional researchers initially dismissed these reports, but further investigation revealed that Steve represents a completely new type of atmospheric phenomenon. The discovery of Steve illustrates how much we still don't know about the aurora. Despite centuries of observation and decades of intensive scientific study, the aurora continues to surprise us, revealing new aspects of its behavior and new connections to other atmospheric and space weather phenomena. Aurora research is also benefiting from advances in space technology. Networks of small satellites called cubes. ATS can now monitor aurora activity from multiple vantage points, simultaneously providing three-dimensional views of aurora development and evolution. These space-based observations complement ground-based monitoring to create the most comprehensive picture of aurora behavior ever achieved. The data streaming back from these various monitoring systems is revealing that individual aurora displays are connected across vast distances. What appears as separate aurora activity in Alaska and Scandinavia might actually be part of a single global phenomenon, responding to the same solar wind disturbances and magnetic field variations. This global perspective on the aurora is changing how scientists think about Earth's entire magnetosphere, the bubble of magnetic influence that surrounds our planet, rather than viewing the aurora as a local phenomenon restricted to polar regions. Researchers are beginning to see it as a visible manifestation of planet-wide electromagnetic processes. The aurora also serves as a natural laboratory for studying plasma physics, the fourth state of matter that makes up most of the visible universe. When charged particles from the solar wind interact with Earth's magnetic field and atmosphere, they create plasma conditions that are difficult or impossible to recreate in earthbound laboratories. Understanding these natural plasma processes has practical applications for developing controlled nuclear fusion reactions, designing more efficient spacecraft propulsion systems, and creating better protection for astronauts during long duration space missions. The dancing lights above the Arctic are teaching us fundamental lessons about physics that may ultimately help humanity expand beyond Earth as we look toward the future of human space exploration. Aurora research becomes even more relevant. Other planets in our solar system experience their own versions of aurora phenomena, and understanding these displays will be crucial for protecting future astronauts and colonists from harmful radiation. Jupiter's aurora, for example, is powered by a completely different mechanism than Earth's instead of solar wind particles. Jupiter's aurora is created by charged particles from its volcanic moon, Io interacting with Jupiter's powerful magnetic field. Studying these differences helps scientists understand the full range of possible aurora phenomena throughout the universe. The search for life beyond our solar system also benefits from aurora research planets. Orbiting other stars might experience aurora displays that could be detectable with future space telescopes. These exoplanet auroras could provide crucial information about planetary magnetic fields, atmospheric composition, and the potential habitability of distant worlds. But even as aurora science advances toward these cosmic horizons, the fundamental human experience of witnessing the aurora remains unchanged. There's still something profoundly moving about. Standing beneath those dancing lights, feeling connected to forces that dwarf human understanding and human timescales. The aurora reminds us that we live in a universe of constant motion and change where invisible energies flow between worlds, carrying information and influence across vast distances of space and time. Every aurora display is a message from our star, written in a language of light that speaks directly to something deep within human consciousness. As you contemplate the aurora, whether from the comfort of your bed or through the lens of scientific understanding, remember that you're witnessing one of nature's most perfect demonstrations of connectivity and interdependence. The sun, the earth, the magnetic field, the atmosphere, the very atoms in your body, all participating in this cosmic dance of light and energy. The aurora teaches us that boundaries are more fluid than they appear. The edge of space, the separation between earth and sky, the distinction between living and non living matter. All these boundaries become permeable when we view them through the lens of electromagnetic connection and atomic interaction. And perhaps that's the aurora's greatest gift. Not just its beauty, though that alone would be sufficient, but its ability to expand our sense of what's possible, to remind us that we live in a universe far stranger and more wonderful than our daily experience might suggest, where particles of light carry messages from the sun and paint them across the sky in colors that seem too beautiful to be real, but are as real as anything else in this strange and lovely cosmos we call home. Somewhere in that interplay between the cosmic and the intimate lies another layer of aurora magic that scientists are only beginning to understand. The aurora doesn't just dance in the sky above us, it also sings, though this celestial music requires special instruments to hear. Radio waves generated by the same processes that create the visual aurora produce what researchers call auroral chorus, a haunting ethereal sound that resembles whale songs or wind chimes made of starlight. These radio emissions sweep up and down in frequency, creating melodies that seem almost deliberately composed as if the aurora were a vast instrument played by invisible hands. The indigenous peoples of the far north have long claimed they could hear the aurora with their own ears, describing soft, crackling sounds, whooshing noises, or gentle whispers that accompany the brightest displays. Modern science has struggled to explain this auditory phenomenon. Some researchers suggest that the electromagnetic fields associated with aurora activity might cause tiny sparks in the dry Arctic air, creating barely audible sounds that reach the ground. Whether real or imagined, these reported aurora sounds add another dimension to the sensory experience of witnessing the northern lights. They remind us that the aurora engages more than just our sense of sight. It can touch something deeper, something that responds to beauty in ways we don't fully understand or need to understand. The aurora also varies with the seasons in ways that go beyond simple darkness and daylight during the Arctic summer when the sun never fully sets. The aurora continues its dance, but becomes invisible against the bright sky. It's still there, still painting the same colors, at the same altitudes, but hidden from human eyes, like a secret performance for an audience that doesn't need to see to appreciate this hidden summer. Aurora has only recently become visible to us through specialized cameras and instruments that can detect the faint light against the bright background of the midnight sun. These observations have revealed that aurora activity actually peaks during the summer months when magnetic conditions are optimal, even though we can't see it with the naked eye. The invisible aurora serves as a reminder that so much of what shapes our world happens beyond the reach of our senses. The electromagnetic forces that govern aurora behavior are always present, always active whether we can perceive them or not, like a vast underground river flowing beneath the landscape of our daily experience. Aurora researchers have also discovered that the phenomenon extends far beyond the visible light spectrum into wavelengths our eyes cannot detect. Infrared aurora provides information about atmospheric heating, while ultraviolet aurora reveals details about atmospheric chemistry. Each wavelength tells a different part of the story, like instruments in an orchestra, each contributing their unique voice to the overall symphony. The more we study the aurora, the more we realize how much it resembles other natural phenomena that seem completely unrelated. The way aurora curtains ripple and flow mirrors the behavior of ocean waves or sand dunes shaped by wind. The spiral structures that sometimes form in aurora displays follow mathematical patterns found in seashells' galaxies and the arrangement of seeds in a sunflower. These similarities aren't coincidental. They reflect fundamental principles of physics that apply across vastly different scales and systems. The same mathematical relationships that govern fluid dynamics in the atmosphere also shape the formation of river deltas, the growth of trees, and the structure of lightning bolts. The aurora connects us not just to space weather, but to the deep mathematical harmony that underlies all natural phenomena. This mathematical beauty becomes even more apparent when aurora researchers create computer models to simulate aurora behavior. The equations that describe how charged particles move through magnetic fields, how atoms absorb and emit energy, how electromagnetic waves propagate through plasma. These equations produce patterns and structures that mirror exactly what we see in real aurora displays. It's as if the universe were written in a language of mathematics, and the aurora serves as one of nature's most elegant translations, making abstract equations visible in flowing curtains of light that anyone can appreciate without needing to understand the underlying mathematics. The aurora also teaches us about the nature of time itself. Each photon of aurora light represents a moment when past, present, and future converge. The charged particle that creates that photon began its journey at the sun days or weeks earlier, traveled through space at incredible speeds, interacted with Earth's magnetic field, and finally collided with an atmospheric atom at precisely the right moment to create that specific flash of light. In that sense, every aurora display is a kind of time machine, showing us the culmination of processes that began long before we started watching. The light reaching our eyes carries information about solar activity that occurred in the recent past, while the atoms creating that light have been part of Earth's atmosphere for millions of years. The oxygen atoms glowing green in tonight's aurora might have been breathed by dinosaurs or absorbed by ancient forests. They've cycled through countless living organisms, been part of rock formations, ocean water, and ice crystals. Now they're participating in this cosmic light show before eventually returning to the endless cycle of atmospheric circulation. This deep time perspective adds another layer of meaning to aurora observation. When you watch the northern lights, you're witnessing not just a beautiful natural phenomenon, but a moment in the ongoing story of matter and energy that connects the formation of the solar system to the distant future when our sun will expand into a red giant and aurora displays will be very different or perhaps non existent. The aurora also serves as a bridge between different ways of knowing about the world. Scientific instruments can measure the precise wavelengths of aurora. Light calculate the energy of incoming particles and predict when displays are likely to occur, but they cannot capture the emotional impact of standing beneath the skies filled with dancing light, or the sense of connection to something larger than ourselves. Indigenous knowledge systems offer different insights into aurora behavior based on thousands of years of careful observation passed down through oral traditions. These systems recognize patterns and relationships that complement scientific understanding, providing a more complete picture of how the aurora fits into the larger web of Arctic life. For example, traditional ecological knowledge from various Arctic communities describes correlations between aurora activity and animal behavior, weather patterns, and seasonal changes. These observations often focus on subtle details that scientific instruments might miss because they're embedded in a deep understanding of local environmental conditions. Modern researchers are increasingly recognizing the value of combining scientific methods with traditional knowledge, creating more comprehensive and nuanced understanding of complex natural phenomena like the aurora. This collaborative approach respects different ways of knowing while advancing our overall understanding of how the world works. The aurora also plays a role in the cultural identity of Arctic communities for many people living in the far north. The aurora isn't just a natural phenomenon to be studied or photographed. It's part of the landscape of home, as familiar and meaningful as mountains, forests, or rivers. Children growing up in places like Fairbanks, Yellowknife, or Tromsø learn to read aurora conditions the way children in other climates learn to read weather patterns. They develop an intuitive sense of when the aurora is likely to appear, what different types of displays might indicate, and how aurora activity connects to other aspects of their environment. This intimate familiarity with the aurora creates a different kind of relationship with the phenomenon than what most visitors experience for local residents. The aurora becomes part of the rhythm of life, providing beauty and wonder on long winter nights, but also serving as a natural calendar marking the passage of seasons and the changing conditions of Arctic life. Aurora photography has also evolved into a sophisticated art form that requires not just technical skill, but deep understanding of aurora behavior, weather patterns, and the unique challenges of working in Arctic conditions. The best aurora photographers combine scientific knowledge with artistic vision, waiting patiently in remote locations for the perfect combination of clear skies, active aurora, and compelling foreground elements. But perhaps even more important than the technical aspects of aurora photography is the patience and dedication it requires. You might wait hours or even days in sub zero temperatures for conditions to align properly, and even then, there's no guarantee that the aurora will appear or that it will create the kind of display worth photographing. This uncertainty is part of what makes aurora photography so rewarding when everything does come together. The combination of natural beauty, technical challenge, and personal persistence creates images that capture not just the visual appearance of the aurora, but something of the experience of witnessing it. Time lapse photography has revealed aspects of aurora behavior that were invisible to previous generations of observers. By compressing hours of aurora activity into minutes of video time lapse, sequences show the complex choreography of aurora motion, the way different parts of the display respond to changing magnetic conditions, and the intricate relationships between aurora structure and atmospheric dynamics. These time lapse sequences often reveal that what appears to be chaotic dancing light actually follows sophisticated patterns and structures. The aurora moves like a vast atmospheric organism, responding to stimuli processing energy and expressing the results through coordinated changes in brightness, color, and form. Social media has democratized aurora photography, allowing people around the world to share their aurora experiences instantaneously. This global sharing has created a kind of collective aurora consciousness where observers in different locations can compare their experiences and contribute to a worldwide understanding of aurora patterns and behavior. But social media, aurora photography, also raises questions about authenticity and representation. Many aurora photographs are heavily processed to enhance colors and contrast that might not be visible to the naked eye. While these enhanced images can be stunningly beautiful, they sometimes create unrealistic expectations about what aurora viewing actually looks like. The debate over aurora photography authenticity reflects larger questions about the relationship between experience and documentation, between what we see and what we share, between the private moment of wonder and the public act of communication. Perhaps the most honest answer is that both approaches have value. Scientific documentation that accurately represents what instruments detect serves one purpose, while artistic interpretation that captures the emotional impact of aurora viewing serves another. The aurora is large enough and complex enough to accommodate multiple ways of seeing and understanding. Aurora viewing has also become a significant form of ecotourism, bringing economic benefits to remote northern communities, while also creating new challenges related to light pollution, traffic, and environmental impact. The popularity of aurora tourism has led to the construction of specialized viewing facilities, hotels designed for aurora observation, and tour services that transport visitors to optimal viewing locations. This commercialization of aurora viewing creates both opportunities and concerns. On one hand, it provides economic incentives for preserving dark skies and maintaining the natural conditions necessary for good aurora visibility. On the other hand, it risks turning a profound natural experience into a commodity to be consumed rather than a phenomenon to be contemplated. The most successful aurora tourism operations seem to be those that balance commercial viability with respect for the natural phenomenon and the communities where it occurs. They provide visitors with not just opportunities to see the aurora, but also education about aurora science, local culture, and the importance of protecting the dark skies that make aurora viewing possible. Climate change adds another layer of complexity to aurora tourism and aurora science as the Arctic warms. Weather patterns change, potentially affecting cloud cover, precipitation, and atmospheric conditions that influence aurora visibility. While the fundamental physics of aurora formation won't change with climate change, the practical experience of aurora viewing might be significantly altered. Aurora research is also contributing to our understanding of climate change by providing long term data about upper atmospheric conditions and electromagnetic activity. These high altitude processes don't directly control surface weather, but they're part of the complex system of atmospheric interactions that influence climate patterns. The aurora serves as a kind of natural instrument for monitoring the health of Earth's electromagnetic environment. Changes in aurora patterns, frequency, or intensity can indicate shifts in solar activity, magnetic field strength, or atmospheric composition that might have broader implications for Earth's climate system. As we look toward the future, aurora science promises to reveal even more about the connections between solar activity, terrestrial climate, and the complex electromagnetic environment that surrounds our planet. New generations of satellites, ground based instruments, and computational models will provide unprecedented detail about aurora processes. But perhaps the most important future for aurora science lies not in more sophisticated instruments or complex theories, but in maintaining the sense of wonder and connection that draws people to study the aurora in the first place. The aurora reminds us that we live in a universe of beauty and mystery where invisible forces create visible magic on a nightly basis. The aurora also teaches us about resilience and adaptation throughout Earth's history. The magnetic field that creates the aurora has fluctuated in strength and orientation, sometimes disappearing entirely during magnetic reversals. Yet life has persisted and even thrived, suggesting that the electromagnetic environment that gives us the aurora is more flexible and robust than we might expect. This resilience extends to the aurora itself. Despite increasing light pollution, technological interference, and atmospheric changes, the aurora continues to dance above the polar regions, painting the same colors, following the same magnetic highways, responding to the same solar rhythms that have governed its behavior for millions of years. There's something profoundly comforting about this continuity. The knowledge that regardless of human activities or technological changes, the aurora will continue its ancient dance. As long as the sun shines and the earth maintains its magnetic field, it connects us to deep time and cosmic rhythms that extend far beyond human concerns. The aurora also reminds us of our responsibility as temporary stewards of this remarkable planet. The dark skies necessary for aurora viewing are becoming increasingly rare as light pollution spreads across the globe. Protecting these remaining dark sky areas isn't just about preserving aurora tourism, it's about maintaining our connection to the natural world and the cosmic context in which we live. Every clear, dark night when the aurora dances above the polar regions is a gift, an opportunity to witness one of nature's most spectacular displays and to remember our place in the larger story of the universe. The aurora doesn't dance for us, but we're extraordinarily fortunate to be able to see it as artificial intelligence. And machine learning begin to analyze vast amounts of aurora data, we're discovering patterns and relationships that were invisible to human observers. These computational approaches are revealing that the aurora is even more structured and predictable than we previously realized, while still maintaining its capacity for surprise and spontaneous beauty. The aurora teaches us that science and wonder are not opposites, but partners in the quest to understand our world. The more we learn about the precise mechanisms that create aurora displays, the more amazing and beautiful they become. Knowledge doesn't diminish wonder, it amplifies it. And perhaps that's the aurora's greatest lesson, that the universe is simultaneously comprehensible and mysterious, governed by precise physical laws, yet capable of creating beauty that touches something deep in human consciousness. The aurora bridges the gap between knowledge and experience, between measurement and meaning. Tonight, as the solar wind streams past Earth and charged particles follow invisible magnetic highways toward the polar regions, the aurora prepares for another performance, whether anyone is watching or not, whether skies are clear or cloudy, whether cameras are ready or eyes are closed. The aurora dances. It dances because the sun shines and the earth spins, and magnetic fields guide charged particles through space in patterns as old as the solar system itself. It dances because physics demands it, because electromagnetic forces require it, because the very structure of space and matter makes it inevitable. But from our human perspective, the aurora dances because beauty is built into the fabric of reality, because the universe has a sense of aesthetics that expresses itself in flowing curtains of light that seem designed specifically to inspire awe in conscious beings capable of appreciating such displays. The aurora reminds us that we live in a cosmos where matter and energy constantly transform themselves, creating temporary patterns of incredible beauty before dissolving back into the eternal dance of particles and forces that will continue long after we're gone. Yet for this brief moment in cosmic time, we get to watch, and in watching, we become part of the story, participants in the ongoing conversation between matter and consciousness, between the universe and the minds that have evolved within it to contemplate its beauty. The aurora doesn't need us to appreciate it, but our appreciation somehow completes the circle, connecting the cosmic dance to the human heart. So perhaps that's where we find ourselves tonight, floating somewhere between scientific understanding and pure wonder, between the measurable mechanics of charged particles and the unmeasurable magic of standing beneath a sky that suddenly decides to glow with colors that seem borrowed from dreams. The aurora has taught us so many things about our planet, our solar system, and our place within the vast electromagnetic web that connects all things. We've learned that beauty and physics are not separate realms, but different ways of experiencing the same underlying reality. We've discovered that the most spectacular displays in nature often arise from the most fundamental processes, that invisible forces can create visible poetry, and that the universe has a way of making the complex appear effortlessly simple. But perhaps the aurora's most profound lesson is about connection. Every time those dancing lights appear above the polar regions, they're demonstrating the intricate relationships that bind our world to the cosmos. The sun doesn't create the aurora alone, nor does the earth. It emerges from their interaction, from the delicate balance between solar energy and planetary magnetism, from the precise chemistry of atmospheric gases and the quantum mechanics of atomic excitement. This interconnectedness extends far beyond the aurora itself. The same processes that paint light across Arctic skies also influence weather patterns, animal migrations, and the very evolution of life on Earth. The magnetic field that channels aurora creating particles also shields us from harmful radiation, making complex life possible in the first place. We exist within a web of relationships so intricate that changing any single element would transform the entire system. Indigenous peoples understood this interconnectedness long before modern science could measure and quantify it. Their stories and traditions treat the aurora not as an isolated phenomenon, but as part of a larger conversation between sky and earth, between visible and invisible forces, between the physical and spiritual dimensions of existence. These traditional knowledge systems remind us that understanding involves more than measurement, that wisdom includes both facts and feelings, both data and dreams. The aurora also teaches us about time, about the patience required to witness truly extraordinary events. You might travel thousands of miles to the Arctic Circle, wait through cloudy nights and quiet magnetic conditions, only to be rewarded with a brief glimpse of green light on the horizon. Or you might step outside on an ordinary evening and find the entire sky transformed into a cathedral of flowing light that takes your breath away and changes how you see the world forever. This unpredictability is part of the aurora's gift. In our age of instant gratification and on demand entertainment, the aurora insists on its own schedule. It appears when solar conditions align with terrestrial magnetism, when atmospheric chemistry permits, when the cosmic clockwork of our solar system creates just the right circumstances for invisible particles to become visible light. The aurora teaches us that some things cannot be summoned or controlled, only witnessed with patience and gratitude when they choose to reveal themselves. The colors themselves carry their own mysteries. That ethereal green that dominates most aurora displays exists at the precise intersection of solar energy and atmospheric oxygen, at exactly the wavelength where human eyes are most sensitive to green light. Is this coincidence, or does it suggest something deeper about the relationship between consciousness and cosmos, between the observer and the observed? Perhaps we're drawn to aurora green because it represents the perfect balance between the energy of space and the matter of earth, between the dynamic and the stable, between change and permanence. Aurora research continues to reveal new aspects of this ancient phenomenon. Citizen scientists around the world contribute observations that help professional researchers track patterns and discover anomalies. Smartphone apps allow anyone to report aurora sightings, creating a global network of observers that spans time zones and continents. This democratization of aurora science reminds us that wonder and curiosity are universal human traits, that the desire to understand and appreciate natural beauty transcends cultural and geographic boundaries. The future promises even more sophisticated understanding as artificial intelligence analyzes vast amounts of aurora data, as space based instruments provide new perspectives, as our models of solar terrestrial interaction become more precise and predictive. But no amount of scientific advancement will diminish the fundamental human experience of standing beneath an aurora display and feeling connected to something larger than ourselves. The aurora also serves as a bridge between different ways of knowing about the world. Scientific instruments can measure wavelengths, count particles, and predict magnetic disturbances, but they cannot capture the emotional impact of witnessing your first aurora, the sense of profound connection to cosmic forces. The way aurora light seems to bypass rational thought and speak directly to something deeper in human consciousness. Photographers attempt to capture aurora beauty, but their images, however stunning, represent only a fraction of the full experience. The aurora exists in four dimensions, changing constantly as you watch, responding to invisible fluctuations in space weather, creating patterns that exist for mere moments before dissolving into new configurations. It's a phenomenon that must be experienced rather than merely observed, felt rather than simply seen. The aurora reminds us that we live in a universe where beauty emerges spontaneously from the intersection of physical forces. No conscious designer arranges the colors or choreographs the movements, yet the result appears almost deliberately artistic, as if the universe possessed an aesthetic sense that expresses itself through the interaction of matter and energy. This suggests something profound about the nature of reality itself, about the relationship between physics and poetry, between scientific law and natural artistry. Climate change adds urgency to aurora appreciation as the Arctic warms and weather patterns shift. While the fundamental physics of aurora formation won't change, the practical experience of aurora viewing might be significantly altered. Increased cloud cover, changing precipitation patterns, and shifting atmospheric conditions could make clear aurora viewing more difficult, even as the underlying electromagnetic processes continue unchanged. This reminds us that our window of opportunity to experience the aurora, as previous generations have known it may be limited. The dark skies necessary for optimal aurora viewing are already threatened by light pollution, and climate change may further reduce viewing opportunities. Every clear night when the aurora dances becomes more precious, every successful aurora viewing expedition more remarkable. The aurora also connects us to the deep future as well as the ancient past. Billions of years from now, when our sun expands into a red giant, Earth's magnetic field and atmosphere will be very different. The aurora displays of that distant epoch, if they exist at all, will follow different patterns, paint different colors, dance to different rhythms. But for now, in this brief moment of cosmic time, we get to witness the aurora as it has appeared for millions of years, painting the same greens and purples across polar skies, following magnetic field lines that have guided charged particles since Earth developed its protective electromagnetic shield. Aurora tourism has introduced millions of people to this natural wonder, creating a global community of aurora enthusiasts who share photographs, compare experiences, and plan expeditions to remote northern locations. This democratization of aurora access has positive aspects, bringing economic benefits to Arctic communities and raising awareness about the importance of protecting dark skies. But it also raises questions about how to balance accessibility with preservation, how to share natural wonders without diminishing them. The most meaningful aurora experiences often happen far from the crowds, in remote locations where artificial light doesn't compete with natural darkness, where the silence is deep enough to hear your own heartbeat, where the aurora appears not as entertainment but as revelation. These solitary encounters with the aurora create memories that last lifetimes, moments of connection with the cosmos that can shift perspective and deepen appreciation for our planet's place in the larger universe. The aurora teaches us patience in an impatient world, wonder in a cynical age, connection in a time of isolation. It reminds us that some things cannot be bought or scheduled or guaranteed, only experienced with openness and gratitude when they choose to appear. It shows us that beauty exists on scales both cosmic and intimate, that the same forces that govern galaxies also paint light across our local sky. Indigenous Arctic communities have always understood that the aurora is more than just a pretty light show. Their traditional stories and observations recognize the aurora as part of a larger system of relationships connecting earth and sky, animals and weather, past and future. These knowledge systems offer insights that complement scientific understanding, providing a more complete picture of how the aurora fits into the web of Arctic life. Modern aurora research increasingly incorporates traditional ecological knowledge, recognizing that indigenous observers have been studying aurora patterns for thousands of generations. Their observations often focus on subtle details that scientific instruments might miss, relationships between aurora activity and animal behavior, correlations with weather patterns, and seasonal changes that emerge only through long-term observation by people whose lives are intimately connected to Arctic conditions. The aurora also serves as a natural laboratory for studying plasma physics, the fourth state of matter that makes up most of the visible universe. When charged particles from the solar wind interact with Earth's magnetic field and atmosphere, they create plasma conditions that are difficult to recreate in terrestrial laboratories. Understanding these natural plasma processes has practical applications for controlled nuclear fusion, spacecraft design, and protection of astronauts during long-duration space missions. As we push toward human exploration of Mars and other planets, aurora research becomes even more relevant. Understanding how different planetary magnetic fields interact with solar wind helps us predict radiation environments that future explorers might encounter. Other planets in our solar system experience their own versions of aurora phenomena, and studying these differences helps scientists understand the full range of possible electromagnetic interactions throughout the universe. The search for life beyond our solar system also benefits from aurora research. Planets orbiting other stars might experience aurora displays that could be detectable with future space telescopes. These exoplanet auroras could provide crucial information about planetary magnetic fields, atmospheric composition, and the potential habitability of distant worlds. The aurora serves as a kind of electromagnetic signature that reveals fundamental characteristics of planetary environments. But beyond all the scientific applications and practical benefits, the aurora remains fundamentally about beauty and wonder about our human capacity to be moved by natural phenomena that dwarf our understanding and humble our pretensions. There's something irreducibly magical about standing beneath dancing lights that connect you directly to the sun, to the magnetic field that protects all life on Earth, to the very atoms that make up your body and the atmosphere around you. The aurora reminds us that we are not separate from the natural world, but part of it, that the electromagnetic forces that create those dancing lights also flow through our nervous systems, that the elements glowing in the aurora are the same elements that form our bones and blood. We are quite literally made of star stuff, and the aurora makes that cosmic connection visible in flowing curtains of light that seem designed to inspire exactly the sense of wonder and connection we feel when we witness them. Every aurora display is both ancient and immediate, following patterns established when Earth first developed its magnetic field, yet unique to the specific moment when solar wind conditions and atmospheric chemistry align to create that particular configuration of light and color. The aurora exists at the intersection of deep time and present moment, of cosmic forces and human perception, of scientific understanding and mystical experience. As our technology advances and our understanding deepens, we're discovering that the aurora is even more complex and beautiful than we previously imagined. New types of aurora phenomena continue to be identified. Subtle variations in color and movement reveal connections to previously unknown atmospheric processes, and the aurora's relationship to climate and space weather proves more intricate than early researchers suspected. But perhaps the most important discovery is that increased knowledge doesn't diminish wonder, it amplifies it. The more we learn about the precise mechanisms that create aurora displays, the more amazing they become. Understanding the quantum mechanics of atomic emission, the fluid dynamics of plasma interactions, and the electromagnetic principles that govern particle motion makes the aurora more miraculous, not less. The aurora teaches us that science and poetry are not opposites, but partners in the quest to understand and appreciate our world. The equations that describe aurora formation are as elegant as the light displays themselves. The mathematical relationships that govern electromagnetic interactions possess their own kind of beauty, and the scientific instruments that measure aurora properties are themselves marvels of human ingenuity and creativity. Tonight, somewhere above the Arctic Circle, the aurora may be beginning its ancient dance. Charged particles that left the sun days ago are approaching Earth's magnetic field, preparing to follow invisible highways toward the polar regions where they will collide with atmospheric atoms and release their energy as light. Whether anyone is watching or not, whether skies are clear or cloudy, the aurora dances because physics demands it, because the universe is structured in such a way that matter and energy must express themselves through beauty. And if you're fortunate enough to witness that dance, if you find yourself standing beneath a sky painted with impossible colors, remember that you're seeing the visible expression of invisible forces that connect everything in the cosmos. You're witnessing the conversation between our planet and our star, between matter and energy, between the laws of physics and the mystery of consciousness that allows you to appreciate such displays. The aurora doesn't need our appreciation to exist, but our appreciation somehow completes the circle, connecting the cosmic dance to the human heart, the electromagnetic symphony to the consciousness capable of recognizing its beauty. In that moment of recognition, we become part of the story, participants in the ongoing dialogue between universe and mind, between the forces that shape reality and the awareness that can contemplate its meaning. The aurora reminds us that we live in a cosmos where beauty emerges spontaneously from the intersection of fundamental forces, where invisible energies create visible poetry, where the same principles that govern the largest structures in the universe also paint light across our local sky on quiet winter nights when conditions align and magic becomes visible to anyone patient enough to look up and wonder. And perhaps that's the most profound gift the aurora offers us in our hurried modern world. The reminder that some things simply cannot be rushed or controlled or summoned on demand. The aurora appears when it chooses, following rhythms far older than human civilization, responding to forces that operated long before we developed the ability to measure and predict them. There's something deeply humbling about this cosmic indifference. The aurora doesn't care about our travel schedules, our photography plans, or our desperate desire to witness something transcendent. It dances according to the ancient choreography of solar magnetism and planetary physics, creating beauty for its own sake. Whether anyone is present to witness it or not, this indifference isn't cold or hostile. It's simply natural, like the way flowers bloom, whether anyone stops to smell them or mountains stand proud, whether anyone climbs them. The aurora exists in that realm of natural phenomena that remind us we are guests in a universe that operates according to principles far grander than our immediate concerns. Yet when we do encounter the aurora, when those curtains of light suddenly appear above the northern horizon, there's an intimacy to the experience that seems almost personal, as if the cosmos has chosen this particular moment to reveal one of its most closely guarded secrets. Just for you. Aurora observers often describe this sensation of being personally addressed by the lights of feeling somehow selected or blessed to witness a display that seems choreographed specifically for their eyes. This is, of course, pure imagination, but it speaks to something deeper about how human consciousness responds to extraordinary beauty. We are pattern seeking creatures, constantly searching for meaning and connection in the natural world around us. The aurora, with its flowing organic movements, its seemingly purposeful choreography, its ability to appear and disappear without warning, triggers something primal in our perception, something that recognizes intention and artistry, even where none exists. This tendency to anthropomorphize the aurora to see personality and purpose in its movements appears across cultures and throughout history. The Inuit saw spirits at play, the Norse saw warriors, the Romans saw goddesses, and we in our scientific age see plasma dynamics and electromagnetic interactions, yet still catch ourselves whispering that the lights are dancing just for us. Perhaps this anthropomorphism isn't entirely wrong. Perhaps consciousness and cosmos are more intimately connected than our current scientific paradigms suggest. The aurora, after all, is created by the same electromagnetic forces that govern neural activity in our brains, the same quantum mechanical principles that determine which colors appear in the sky, also operate in the biochemical processes that create thoughts and memories. When we stand beneath the aurora experiencing that sense of connection and wonder, we are quite literally electromagnetic beings, witnessing an electromagnetic phenomenon using electromagnetic processes in our brains to create the subjective experience of beauty and awe. There's a symmetry here that suggests deeper relationships between observer and observed, between mind and matter. The aurora also teaches us about the nature of time itself. Each photon of light that reaches your eyes from an aurora display represents a precise moment when past, present, and future converge. The charged particle that creates that photon began its journey at the sun perhaps a week ago, traveled through space at nearly unimaginable speeds, interacted with Earth's magnetic field, and finally struck an atmospheric atom at exactly the right instant to produce that specific flash of color. In that sense, every aurora is a kind of temporal intersection, a place where different timescales meet and merge: the deep time of stellar evolution, the medium time of solar cycles, the quick time of space weather, and the immediate time of human perception, all collapse into a single moment of light that exists for perhaps a second before being replaced by the next photon in an endless cascade of present moments. This temporal complexity adds another layer of meaning to aurora observation. When you watch the northern lights, you're not just seeing a beautiful natural phenomenon, you're witnessing the culmination of processes that span vastly different scales of time and space, from the nuclear fusion in the sun's core that created the energy for those charged particles to the quantum mechanical transitions in atmospheric atoms that determine the precise colors you see. The oxygen atoms glowing green in tonight's aurora have been part of Earth's atmosphere for countless millions of years. They've been breathed by ancient creatures, absorbed by prehistoric plants, incorporated into rock formations and ocean water, before finding themselves at precisely the right altitude, with precisely the right energy level to participate in this moment of cosmic theater. There's something profoundly moving about this continuity, about the way matter cycles through different forms and functions while maintaining its essential identity. Those same oxygen atoms might have been part of the first breath you took as a baby, part of the photosynthesis that created the food you ate yesterday, part of the cloud that rained on your garden last spring. The aurora makes this invisible circulation visible for a brief moment, showing us the dance of atoms that usually happens far below the threshold of perception. It's a reminder that we live in a world of constant recycling and renewal, where nothing is ever truly lost, only transformed from one state to another. This perspective can be deeply comforting, especially during times of loss or change. The aurora shows us that endings are also beginnings, that what appears to be destruction is often transformation, that the fundamental stuff of reality persists even as its manifestations shift and change. The aurora also serves as a bridge between the scientific and the spiritual, not because it requires supernatural explanation, but because it demonstrates so clearly the deep interconnectedness of all things. The same forces that create aurora displays also govern the formation of galaxies, the evolution of stars, and the biochemical processes that sustain life. When indigenous peoples described the aurora in spiritual terms, they weren't rejecting scientific understanding. They were recognizing something that our mechanistic worldview sometimes misses: the profound unity underlying apparent diversity, the way individual phenomena emerge from and return to the larger patterns that structure reality. Modern physics increasingly confirms this intuitive understanding. Quantum mechanics reveals that particles are not separate discrete objects, but excitations in underlying fields. Relativity shows that space and time are not fixed containers, but dynamic aspects of a unified space-time fabric. Cosmology demonstrates that everything in the universe emerged from common origins and remains connected through invisible influences. The aurora embodies these insights in visible form, showing us how local phenomena arise from global processes, how individual events reflect universal principles, how beauty and meaning emerge spontaneously from the intersection of fundamental forces. But perhaps the aurora's deepest teaching concerns our relationship with mystery in our age of instant information and comprehensive databases. There's something refreshing about encountering a phenomenon that retains its capacity to surprise and humble us. Despite decades of intensive study, the aurora continues to reveal new aspects of its behavior, new types of displays, new connections to other atmospheric and space weather phenomena. Scientists regularly discover aurora phenomena that don't fit existing models, that challenge current understanding, that remind us how much we still don't know. This ongoing mystery isn't a failure of science, but one of its greatest gifts. It keeps us curious, keeps us questioning, keeps us open to wonder and surprise in a world that often seems completely mapped and measured. The aurora reminds us that mystery and knowledge are not opposites, but dance partners, each making the other more beautiful. The aurora teaches us to embrace uncertainty not as a source of anxiety, but as a doorway to wonder. It shows us that we can appreciate and even love things we don't fully understand, that mystery enhances rather than diminishes beauty, that some questions are more valuable than their answers. This comfort with mystery becomes increasingly important as we face the challenges of the 21st century: climate change, technological disruption, social transformation. All these require us to act wisely in the face of incomplete information, to make decisions while acknowledging the limits of our knowledge. The aurora provides a model for this kind of relationship with uncertainty. It shows us how to remain curious and engaged while accepting that some things will always exceed our complete comprehension, how to find meaning and beauty in phenomena that resist simple explanation, how to maintain wonder in the face of complexity. Aurora observers often report that their most memorable experiences came not from the most spectacular displays, but from the quiet moments of connection with something larger than themselves. The sense of standing at the intersection of earth and sky, of past and future, of known and unknown. These moments of aurora-induced contemplation can shift perspective in lasting ways. They remind us that we are part of something magnificent and mysterious, that our daily concerns exist within a vast context of cosmic forces and natural beauty, that we are simultaneously insignificant in the face of the universe and precious as the only known conscious observers of its wonders. The aurora also teaches us about patience and presence in our distracted age. It rewards those who can wait quietly in the cold darkness without guarantee of success, who can appreciate subtle changes in light and color, who can find beauty in the process of watching as much as in the spectacle itself. Aurora photography has become increasingly sophisticated, but the most experienced aurora photographers often speak about the importance of putting down the camera periodically and simply experiencing the display with their own eyes without the mediation of technology. There's something about direct sensory engagement with the aurora that cannot be captured or replicated. This direct experience creates memories that are qualitatively different from photographs or videos. Memories that include not just visual information, but the feeling of cold air on your face, the sound of snow crunching underfoot, the sense of scale and space that comes from standing beneath an infinite sky. These embodied memories of aurora encounters often prove more lasting and meaningful than any documentation. They become part of your personal history in a way that observed phenomena rarely do they change, not just what you know, but who you are. The aurora reminds us that we are embodied creatures living in a physical universe, that our most profound experiences involve not just our minds, but our whole beings, that understanding includes not just intellectual comprehension, but felt knowledge. This holistic way of knowing becomes increasingly important as we navigate a world that often privileges abstract information over lived experience. The Aurora teaches us to value both kinds of knowledge, to see them as complementary rather than competing approaches to understanding reality as Aurora research becomes more sophisticated, as we develop better instruments and more accurate models. As artificial intelligence helps us process vast amounts of Aurora data, we risk losing this embodied way of knowing if we're not careful. The challenge for future Aurora science will be to maintain the sense of wonder and direct engagement that has always drawn people to study this phenomenon, to remember that the most sophisticated instruments are tools for enhancing rather than replacing human observation and appreciation. The aurora also provides a powerful antidote to the anthropocentrism that often colors our relationship with the natural world. It reminds us that we live on a planet that is itself a dynamic participant in larger cosmic processes, that Earth is not a passive stage for human activity, but an active player in the electromagnetic drama of the solar system. This perspective can be both humbling and empowering. Humbling because it reveals how small we are in the context of planetary and solar forces, empowering because it shows us that we are part of something magnificent that extends far beyond human society and human timescales. The aurora teaches us to think on multiple scales, simultaneously, to see the local within the global, the temporary within the eternal, the human within the cosmic. This kind of multi scale thinking becomes increasingly important as we face challenges that operate across different dimensions of space and time. Climate change, for example, requires us to understand how local actions aggregate to global consequences, how decisions made today will affect conditions decades in the future, how human activities interact with natural systems that operate on geological timescales. The aurora provides practice for this kind of thinking by showing us how solar activity, space weather, and atmospheric chemistry combine to create local displays of light. The aurora also demonstrates the importance of cycles and rhythms in natural systems. The 11-year solar cycle creates predictable patterns of aurora activity. Seasonal variations in Earth's orientation affect patterns that structure natural phenomena, the way aurora visibility daily rotation zone. Understanding these cycles brings different regions into the aurora, helps us appreciate the deep, individual events fit into larger rhythms. The importance of timing and synchronization in natural systems living according to natural cycles rather than purely artificial schedules. Modern life often disconnects us from these natural rhythms. We live by clock time rather than solar time work in artificially lit environments that mask the daily cycle of light and darkness, travel across time zones in ways that confuse our circadian rhythms. The aurora reconnects us to cosmic time, to the deep rhythms that have governed life on Earth for billions of years. This reconnection with natural cycles can have profound effects on well being and perspective. It reminds us that we are part of natural systems that have their own timing, their own seasons, their own patterns of activity and rest. The aurora teaches us to respect these natural rhythms, to work with them rather than against them, to find our place within the larger patterns that govern planetary and solar system dynamics. As we stand on the threshold of becoming a spacefaring species, the aurora takes on additional significance. It provides a bridge between our earthbound experience and the cosmic environment we may one day inhabit. It shows us what electromagnetic interactions look like on planetary scales, gives us practice thinking about space weather and radiation environments. Future human settlements on Mars or other planets will need to understand and work with very different electromagnetic environments. The aurora research we conduct here on Earth provides crucial knowledge for protecting human life and technology in these alien electromagnetic landscapes. The aurora also reminds us of the preciousness of Earth's particular electromagnetic environment, the delicate balance of solar activity, magnetic field strength, and atmospheric composition that creates our familiar green and purple displays. This balance took billions of years to establish and could be disrupted by changes in any of its component parts. Protecting the conditions that make aurora displays possible becomes part of our responsibility as planetary stewards. This includes maintaining dark skies, free from light pollution, preserving the atmospheric chemistry that creates aurora colors, and understanding how human activities might affect the magnetic field that channels aurora creating particles. The aurora teaches us that stewardship involves not just protecting what we can see and touch, but also preserving the invisible conditions that make natural beauty possible. The electromagnetic fields, the atmospheric chemistry, the space weather environment. All these invisible aspects of our planet's system contribute to the phenomena we can observe and appreciate. This invisible stewardship requires a different kind of environmental thinking, one that considers not just direct impacts on living organisms, but also effects on the physical and electromagnetic systems that create the conditions for life and beauty. The aurora provides a model for this kind of systemic thinking by showing us how changes in solar activity can cascade through the magnetosphere and atmosphere to create visible effects on the ground. It demonstrates the interconnectedness of apparently separate phenomena and the importance of understanding whole systems rather than just individual components. As we contemplate the aurora from our warm beds or comfortable chairs, we might reflect on the extraordinary chain of circumstances that make such contemplation possible. The nuclear fusion in the sun that provides energy for charged particles, the convection in Earth's core that generates our magnetic field, the atmospheric chemistry that creates the colors we see. We might also reflect on the remarkable evolution of consciousness that allows us to appreciate such displays, the long history of life on Earth that led to beings capable of wonder and scientific understanding, the cultural evolution that created language and art and technology sophisticate. The aurora reminds us that we'd enough to study and share aurora experiences are the universe becoming conscious of itself through us matter that has organized itself into patterns complex enough to contemplate its own existence and find beauty in the processes that created it. We are stardust that has learned to look up at the sky and feel moved by the dance of light and magnetism. This perspective can be overwhelming, but also profoundly meaningful. It suggests that our capacity for wonder and appreciation is not separate from the natural world, but part of it, that consciousness is not an accident, but an emergent property of matter, organized in sufficiently complex ways. The aurora teaches us that beauty and meaning are not human inventions projected onto an indifferent universe, but aspects of reality that become visible when matter achieves sufficient complexity to recognize and appreciate its own patterns. This recognition carries responsibility as conscious beings capable of appreciating natural beauty. We have obligations not just to preserve that beauty for future generations, but to cultivate our own capacity for wonder and appreciation, to remain open to the extraordinary that surrounds us constantly. The aurora reminds us that wonder is not a luxury, but a necessity, that our capacity for awe and appreciation connects us to the deeper patterns that structure reality, that maintaining this capacity requires practice and attention and willingness to be surprised tonight. As you prepare for sleep, you might carry with you the image of those dancing lights painting impossible colors across the polar sky. Remember that they dance, whether we watch or not, following patterns older than human civilization, responding to forces that connect our planet to our star, to the galaxy, to the universe itself. In your dreams, you might find yourself standing in that crystalline Arctic air, feeling the cold bite of the wind, watching ribbons of green and purple light flow across the star-filled darkness, feeling connected to something vast and beautiful and mysterious that extends far beyond the boundaries of human understanding, yet somehow includes and embraces your small human wonder. The aurora teaches us that we are part of something magnificent, even when we cannot fully comprehend it, that beauty exists on scales both cosmic and intimate, that the same forces that create spectacular displays of light also flow through our own electromagnetic beings, connecting us to the dance of energy and matter that is the universe itself. And perhaps that's enough. Perhaps it's more than enough to know that we live in a cosmos where charged particles racing through space can paint light across the sky in colors that seem too beautiful to be real, but are as real as anything else in this strange and lovely universe we call home. So, as our gentle journey through the aurora's mysteries draws toward its close, let's pause for a moment to consider what this luminous phenomenon tells us about the art of seeing itself. You see, the aurora has taught generations of observers that there are layers upon layers of reality surrounding us at every moment, most of which remain invisible until conditions align just perfectly to reveal them. Think about it for a moment. Right now, as you listen to these words, charged particles are streaming past Earth in an invisible river. Magnetic field lines are threading through the space around you like the strings of some cosmic harp, and atoms in the upper atmosphere are quietly waiting for their moment to glow. All of this is happening constantly, whether we notice it or not, whether the sky is clear or cloudy, whether anyone is looking up or everyone is looking down at their phones. The aurora reminds us that the world is far stranger everyday experience suggests. We and more wonderful than our walk through life, surrounded by electromagnetic fields, quantum interactions, and cosmic influences that operate on scales both vast and minute. Yet most of the time we're completely unaware of this invisible choreography. The aurora is like a brief lifting of the veil, a moment when the hidden becomes visible, when the ordinary skies transforms into something that seems almost too magical to believe. But here's what's truly remarkable. This magic isn't separate from science, it's the direct result of it. The more we understand about the precise mechanisms that create aurora displays, the more miraculous they become. Knowledge doesn't diminish wonder, it amplifies it. When you know that the green light dancing above the Arctic comes from oxygen atoms releasing photons at exactly 557.7 nanometers, when you understand that each flash of light represents a cosmic conversation between our planet and our star, the aurora becomes not less mysterious, but more so. This is perhaps one of the aurora's most profound gifts. It teaches us that science and poetry are not opposites, but partners in the dance of understanding. The equations that describe electromagnetic interactions possess their own elegant beauty, while the visual spectacle of the aurora provides a visceral reminder of why we're drawn to understand the natural world in the first place. We study the aurora not just to predict when it will appear, but because something in us recognizes that such beauty demands attention, contemplation, perhaps even reverence. The aurora also serves as a bridge between different ways of knowing about our world. Indigenous peoples of the Arctic developed sophisticated systems for reading aurora patterns, understanding their connections to weather, animal behavior, and the rhythms of the natural world. Their knowledge, passed down through countless generations, offers insights that complement modern scientific understanding. They remind us that there are many ways to be in relationship with natural phenomena, many forms of knowledge that can deepen our appreciation and understanding. Modern aurora science increasingly recognizes the value of these traditional knowledge systems, not as quaint folklore, but as sophisticated observational frameworks developed over thousands of years by people whose lives depended on reading the subtle signs of their environment. When Inuit elders speak of aurora patterns that predict weather changes, or when Sami reindeer herders describe how aurora activity affects animal behavior, they're sharing insights that emerge from intimate, long-term relationship with the natural world. This integration of different knowledge systems points towards something important about how we might approach the mysteries that surround us. Perhaps the deepest understanding comes not from choosing between scientific and traditional ways of knowing, but from weaving them together, allowing each to illuminate aspects that the other might miss. The aurora is large enough, complex enough to accommodate multiple perspectives, multiple ways of seeing and understanding. The aurora also teaches us about presence, about the art of paying attention in a world full of distractions. Aurora observers quickly learn that the lights reward patience, stillness, and the willingness to simply be present with whatever unfolds. You can't hurry an aurora display or force it to appear on schedule. You can only create the conditions for witnessing, finding a dark location, checking the forecasts, dressing warmly, and then practice the ancient art of waiting with open attention. This quality of presence, This willingness to wait without guarantee runs counter to much of our contemporary experience. We live in an age of instant everything, of on demand entertainment and immediate gratification. The aurora insists on its own timing, following rhythms far older than human civilization, responding to forces that operate according to cosmic rather than human schedules. There's something deeply refreshing about this cosmic indifference, this reminder that some things simply cannot be rushed or controlled. When aurora displays do appear, they reward this patience with experiences that seem to exist outside normal time. Aurora observers often report losing track of hours while watching the lights dance, becoming so absorbed in the display that they forget cold, fatigue, and the ordinary concerns of daily life. These moments of complete absorption, of presence so total that the boundary between observer and observed seems to dissolve, offer a taste of what contemplative traditions have long recognized as essential to human well being. The aurora creates what we might call sacred time, not sacred in any religious sense necessarily, but sacred in the sense of being set apart from ordinary experience, marked by qualities of attention and appreciation that transform both the observer and the observed. In these moments, watching the aurora becomes a form of meditation, a practice of pure awareness that connects us to something larger than our individual concerns. This meditative quality of aurora observation has practical benefits as well. In our hyper-connected age, the aurora offers an invitation to disconnect from digital devices and reconnect with direct sensory experience. Aurora photographers quickly learn that they need to put down their cameras periodically and simply witness the display with their own eyes, allowing themselves to be present with the phenomenon rather than constantly trying to capture it. This balance between documentation and direct experience reflects a larger challenge in our relationship with natural beauty. How do we share wonder without diminishing it? How do we capture experiences without losing ourselves in the act of capture? The aurora, with its ephemeral beauty and its resistance to perfect reproduction, teaches us that some experiences are meant to be lived rather than merely recorded. The aurora also reminds us of our place within larger cycles and rhythms. The 11-year solar cycle creates predictable patterns of aurora activity, with peak displays occurring during solar maximum when the sun's magnetic field is most active. Seasonal variations in Earth's orientation relative to the solar wind affect aurora frequency and intensity. Even the daily rotation of our planet brings different regions into and out of the aurora zone in predictable patterns. Understanding these cycles helps us appreciate how individual aurora displays fit into larger patterns, how moments of spectacular beauty emerge from the intersection of cosmic rhythms operating on vastly different timescales. The aurora teaches us to think cyclically rather than linearly, to see individual events as part of recurring patterns that connect past, present, and future. This cyclical thinking becomes increasingly important as we face environmental and social challenges that unfold over decades or centuries. Climate change, for instance, requires us to understand how current actions will affect future conditions, how local decisions aggregate to global consequences, how human activities interact with natural cycles that operate on geological timescales. The aurora provides practice for this kind of long term, systems based thinking. The aurora also serves as a reminder of the delicate conditions that make Earth habitable. The magnetic field that creates those dancing lights also protects us from harmful solar radiation. The atmospheric chemistry that produces aurora colors also supports the complex biochemical processes that sustain life. Uh, the same solar activity that creates spectacular light shows can also disrupt the technological systems on which modern civilization depends. This dual nature of space weather, simultaneously beautiful and potentially destructive, reflects a larger truth about our relationship with natural forces. We are utterly dependent on cosmic processes we cannot control, beneficiaries of a planetary system so precisely balanced that small changes could have enormous consequences. The aurora makes this dependence visible, showing us the invisible connections between Earth and space, between local conditions and cosmic influences. As aurora research becomes more sophisticated, as we develop better instruments and more accurate predictive models, we're discovering that the aurora is even more complex and beautiful than previous generations imagined. New types of aurora phenomena continue to be identified. Subtle variations reveal previously unknown atmospheric processes, and the aurora's connections to climate and space weather prove more intricate than early researchers suspected. But perhaps the most important discovery is that increased knowledge enhances rather than diminishes the sense of wonder that draws people to study the aurora in the first place. The more we learn about quantum mechanics of atomic emission, the fluid dynamics of plasma interactions, and the electromagnetic principles that govern particle motion, the more miraculous aurora displays become. This enhancement of wonder through knowledge suggests something profound about the relationship between understanding and appreciation. Rather than explaining away mystery, science reveals deeper layers of mystery. Rather than reducing beauty to mere mechanism, scientific investigation uncovers the elegant principles that make such beauty possible. The aurora teaches us that we can embrace both mystery and knowledge, both wonder and understanding, both scientific precision and poetic appreciation. These are not competing approaches to reality, but complementary ways of engaging with phenomena too rich and complex to be captured by any single perspective. As we look toward the future, aurora science promises revelations we can barely imagine. Artificial intelligence is beginning to identify patterns in aurora behavior that were invisible to human observers. Space-based instruments provide unprecedented detail about the processes that create aurora displays. New generations of ground-based monitoring systems reveal subtle aspects of aurora chemistry and dynamics. But perhaps the most exciting frontier in aurora research involves not new technology, but new ways of integrating different forms of knowledge, new approaches to combining scientific precision with traditional wisdom, new methods for sharing aurora experiences across cultures and continents. The aurora becomes a focal point for exploring how we might approach other complex phenomena that require both rigorous analysis and deep appreciation. The aurora also points toward questions that extend far beyond Earth's magnetosphere. As we discover planets orbiting other stars, we wonder whether they experience their own versions of aurora displays. What would aurora look like on a planet with a different atmospheric composition or magnetic field configuration? Could aurora activity on distant worlds provide clues about their potential habitability? These questions Connect aurora research to the largest questions in science: the search for life elsewhere in the universe, the investigation of how planetary systems form and evolve, the exploration of how consciousness might emerge and develop on other worlds. The aurora serves as a bridge between local phenomena and cosmic questions, between the beauty we can witness directly and the mysteries that stretch across space and time. But even as aurora science pushes toward these cosmic frontiers, the fundamental human experience of aurora observation remains unchanged. There's still something profoundly moving about standing beneath those dancing lights, feeling connected to forces that dwarf human understanding, experiencing beauty that seems designed to inspire exactly the sense of wonder we feel when we witness it. The aurora reminds us that we live in a universe where beauty emerges spontaneously from the intersection of fundamental forces, where invisible energies create visible poetry, where the same principles that govern the formation of galaxies also paint light across our local sky on clear winter nights when conditions align and magic becomes visible. This spontaneous emergence of beauty from natural processes suggests something important about the nature of reality itself. Beauty is not something we impose on an indifferent universe, but something we discover woven into the very fabric of existence. The aurora doesn't become beautiful because we observe it. We're able to recognize its beauty because beauty is an intrinsic aspect of the patterns and relationships that structure the natural world. This recognition of inherent beauty in natural processes has implications that extend far beyond aurora appreciation. It suggests that our aesthetic responses to natural phenomena are not arbitrary cultural constructions, but forms of recognition, ways of acknowledging the elegant principles that govern reality at every scale. The aurora teaches us to trust our sense of wonder, to see it not as a weakness or distraction, but as a form of knowledge, a way of apprehending aspects of reality that purely analytical approaches might miss. Wonder opens us to possibilities we hadn't considered, prepares us to be surprised by beauty in unexpected places, keeps us curious and engaged with the world around us. In our increasingly urbanized and digitized world, maintaining this capacity for wonder requires intentional cultivation. The aurora provides one pathway for this cultivation, offering experiences of natural beauty so powerful that they can reawaken dormant capacities for awe and appreciation. But the lessons of aurora observation, patience, presence, openness to surprise, comfort with mystery, can be applied to encounters with beauty in many forms and settings. The aurora also teaches us about the importance of darkness, both literal and metaphorical. Aurora displays are only visible in truly dark skies, free from the light pollution that increasingly characterizes human settlements. Protecting these remaining dark sky areas becomes not just about preserving aurora viewing opportunities, but about maintaining our connection to the larger cosmic context in which we live. Metaphorically, the aurora reminds us that some forms of illumination require us to embrace rather than flee from darkness. The most profound insights often emerge not from constant, artificial brightness, but from willingness to sit quietly in uncertainty, to wait patiently for understanding to emerge, to remain open to revelations that cannot be forced or scheduled. This comfort with darkness, with the unknown and unknowable, becomes increasingly important as we face challenges that exceed our current understanding or control. Climate change, social transformation, technological disruption, all of these require us to act wisely despite incomplete information, to make decisions while acknowledging the limits of our knowledge. The aurora provides a model for this kind of relationship with uncertainty. Aurora observers learn to appreciate the process of waiting and watching even when displays don't appear, to find meaning in the attempt to witness beauty even when conditions don't cooperate, to maintain hope and attention even when outcomes remain uncertain. This patience with uncertainty, this ability to find meaning in the process rather than demanding guaranteed results, offers valuable practice for navigating an increasingly unpredictable world. The aurora teaches us that some of the most meaningful experiences emerge not from achieving specific outcomes, but from showing up with open attention to whatever unfolds. As we contemplate these lessons, we might also reflect on the remarkable fact that we live at a time when aurora science is advancing so rapidly, when traditional knowledge systems are being recognized and integrated, when citizen science allows anyone to contribute to aurora research. We're witnessing not just the aurora itself, but a transformation in how we study and appreciate natural phenomena. This transformation suggests possibilities for how we might approach other complex challenges, combining rigorous scientific investigation with deep appreciation for beauty and meaning, integrating different forms of knowledge and ways of knowing, maintaining wonder and curiosity even as understanding deepens. The aurora reminds us that we are both observers and participants in the cosmic dance, both students of natural phenomena and expressions of the same creative forces that paint light across polar skies. We are matter that has organized itself into patterns complex enough to contemplate beauty, energy that has evolved the capacity to appreciate elegance, stardust that has learned to look up at the sky and feel moved by the dance of electromagnetic forces. This perspective can be both humbling and empowering. Humbling because it reveals how small we are in the context of cosmic forces. Empowering because it shows that our capacity for wonder and appreciation is itself a remarkable achievement of natural processes. We are the universe becoming conscious of itself, matter learning to recognize and celebrate its own inherent beauty. The aurora teaches us that this recognition carries responsibility. As conscious beings capable of appreciating natural beauty, we have obligations not just to preserve that beauty for future generations, but to cultivate our own capacity for wonder and appreciation, to remain open to the extraordinary that surrounds us constantly, to serve as worthy witnesses to the magnificent cosmos that created us. Tonight, as charged particles continue their ancient dance with Earth's magnetic field, as atoms in the upper atmosphere prepare for their moments of luminous glory, as the aurora continues its patient choreography, whether anyone is watching or not, we can rest in the knowledge that we are part of something vast and beautiful and mysterious. In your dreams, you might find yourself standing beneath those impossible colors, feeling the cold kiss of Arctic air, watching ribbons of light flow across star-filled darkness, understanding with your whole being that you are witnessing not just a natural phenomenon, but a love letter from the cosmos, written in the ancient language of light and magnetism and wonder. The aurora dances on, following magnetic highways older than human memory, painting colors that seem borrowed from some celestial artist's palette, reminding us with every photon of light that we live in a universe where beauty emerges spontaneously from the intersection of fundamental forces, where mystery and knowledge dance together like partners in some cosmic ballet, where consciousness and cosmos meet in moments of recognition so profound they can only be called sacred. And perhaps that's enough. Perhaps that's more than enough to know that we are part of this dance, witnesses to this beauty, participants in this ongoing conversation between matter and meaning, between the forces that shape reality and the awareness that can contemplate and celebrate its magnificent unfolding. The aurora teaches us something else as well, something about the nature of home itself. We often think of home as a specific place, a house, a city, a country, but the aurora reveals a different kind of belonging, one that connects us to the entire electromagnetic environment of our planet. When you witness the aurora, you're seeing your planetary home in action, watching the very processes that make life possible on Earth. The magnetic field that creates those dancing lights is the same field that protects every living thing from harmful cosmic radiation. The atmosphere that glows with aurora colors is the same atmosphere that fills your lungs with every breath you take. This expanded sense of home includes not just the solid ground beneath your feet, but the invisible fields and forces that surround and sustain you. The aurora makes these invisible aspects of our planetary home briefly visible, reminding us that we live within layers upon layers of protection and connection that extend far beyond what we can normally see or touch. There's something deeply comforting about this recognition that we are held and protected by forces we rarely think about: the magnetic field that has shielded Earth for billions of years, the atmosphere that creates just the right pressure and composition for life to flourish, the precise distance from the sun that keeps our planet neither too hot nor too cold for liquid water to exist. The aurora serves as a gentle reminder of this cosmic hospitality, the way our planet provides exactly the conditions necessary, not just for survival, but for beauty, for wonder, for the kind of experiences that make existence meaningful rather than merely endurable. This perspective can shift how we think about environmental protection and planetary stewardship. We're not just preserving resources for human use, but maintaining the delicate conditions that make our planetary home hospitable to the extraordinary diversity of life and beauty that surrounds us. The aurora also teaches us about the art of receiving beauty. We live in a culture that often emphasizes creating, producing, achieving. But the aurora reminds us of the equal importance of simply being present to receive the gifts that the natural world offers freely. You cannot earn an aurora display through effort or deserve it through good behavior. The aurora appears as pure gift, following its own rhythms, responding to cosmic forces that care nothing for human merit or ambition. When it does appear, all you can do is receive it with gratitude and wonder. This practice of receiving beauty without needing to produce or achieve anything in return offers a different model for how we might engage with the natural world and with life itself. The aurora teaches us that some of the most meaningful experiences come not from our own efforts, but from our willingness to be present and receptive to what the universe offers. There's a quality of grace in this kind of receiving an acknowledgement that we are recipients of gifts We didn't create and cannot control, the aurora displays that paint the polar skies exist, whether we witness them or not. But when we do witness them, we become part of something larger than ourselves, participants in a moment of cosmic beauty that connects us to the deep, creative forces of the universe. This sense of grace can transform our relationship with natural phenomena from one of ownership or exploitation to one of gratitude and reciprocity. We don't possess the aurora or control it, but we can receive it with appreciation and perhaps find ways to give something back to the world that offers such generous beauty. The aurora also reminds us about the importance of darkness in our lives, not just the literal darkness necessary for aurora viewing, but the metaphorical darkness of uncertainty, mystery, and the unknown. Our culture often treats darkness as something to be eliminated through artificial light, constant stimulation, endless information. But the aurora teaches us that some forms of illumination require darkness, that the most profound beauty often emerges from quiet, uncertain spaces, that allowing ourselves periods of not knowing, not controlling, not producing, can create openings for experiences we could never have planned or predicted. Aurora observers learn to embrace the darkness, both literal and metaphorical, to sit quietly in cold night air without guarantee of reward, to wait patiently for something that may or may not appear to find meaning in the process of attention itself, rather than demanding specific outcomes. This comfort with darkness, with uncertainty and mystery, becomes increasingly valuable in our rapidly changing world, where the challenges we face often exceed our current understanding, where the solutions we need may require forms of knowledge we haven't yet developed. The aurora provides practice for this kind of relationship with the unknown, teaching us to remain curious and engaged even when outcomes are uncertain, to find beauty in the process of waiting and watching, to maintain hope and wonder even in the face of mystery, as we settle deeper into contemplation of these dancing lights. We might also reflect on how the aurora connects us to the deep future, as well as the ancient past billions of years from now, when our sun expands into a red, giant Earth's magnetic field. An atmosphere will be very different. The aurora displays of that distant epoch, if they exist at all, will follow different patterns, paint different colors, dance to different rhythms. But for now, in this brief moment of cosmic time, we get to witness the aurora as it has appeared for millions of years, painting the same greens and purples across polar skies. This temporal perspective both humbles and elevates us. We are temporary witnesses to phenomena that vastly exceed our individual lifespans, yet our capacity to appreciate and understand these phenomena is itself remarkable, an achievement of natural processes that took billions of years to unfold. The aurora teaches us to hold both perspectives simultaneously, to feel our smallness in the face of cosmic forces while also appreciating the extraordinary fact that the universe has evolved conscious beings capable of witnessing and wondering at its beauty. This dual awareness can inform how we approach our brief time as conscious observers of natural phenomena. We are here for such a short while relative to the age of the earth and the cosmos. Yet during our brief sojourn, we have the remarkable privilege of experiencing beauty that connects us to the deepest structures of reality. The aurora suggests that this privilege carries responsibility not just to preserve natural beauty for future generations, but to develop and cultivate our capacity for wonder and appreciation to become worthy witnesses to the magnificent unfolding of natural processes that surrounds us constantly. There's also something the aurora teaches us about the relationship between science and spirituality, often presented as opposing ways of understanding the world. But the aurora shows us how they can be partners in the quest for deeper appreciation and connection. Scientific understanding of electromagnetic processes, quantum mechanics, and atmospheric chemistry doesn't diminish the spiritual impact of witnessing aurora displays. If anything, deeper knowledge enhances the sense of awe and connection that aurora observation can evoke when you understand that every photon of aurora light represents a precise moment when cosmic forces align to create beauty. When you know that the colors dancing above the Arctic emerge from the same quantum mechanical principles that govern the formation of stars and galaxies, the aurora becomes not less mysterious, but more so. This integration of scientific knowledge and spiritual appreciation offers a model for how we might approach other aspects of our relationship with the natural world. We don't have to choose between rigorous understanding and deep reverence, between precise measurement and profound appreciation. The aurora teaches us that mystery and knowledge are not opposites, but dance partners, each making the other more beautiful, more meaningful, more worthy of our attention and care as our gentle journey through the aurora's many meanings begins to wind toward its close. We might pause to appreciate how this single phenomenon has opened so many doorways to understanding, doorways to physics and chemistry, to history and culture, to philosophy and spirituality, to questions about consciousness and cosmos. The aurora serves as a reminder that natural phenomena are not just objects to be studied, but gateways to deeper understanding of our place in the universe. Each aurora display is simultaneously a scientific event to be measured and analyzed, and a moment of beauty to be witnessed and appreciated. This multiplicity of meaning reflects something important about the richness of natural phenomena and about our capacity as human beings to engage with the world around us in multiple ways. Simultaneously, we are creatures capable of both precise measurement and profound wonder, both rigorous analysis and deep appreciation. The aurora celebrates this human capacity, showing us that we don't have to choose between different ways of knowing, but can embrace them all, allowing each to enrich and inform the others tonight as you drift towards sleep. You might carry with you not just images of dancing lights, but an appreciation for the many ways those lights connect you to the larger story of existence. The aurora dancing above the Arctic connects you to the sun that powers our entire solar system, to the magnetic field that protects all life on Earth, to the atoms that make up your body and everything around you. And so, dear fellow wanderer, as our quiet journey through the aurora's luminous mysteries draws to its gentle close, perhaps you'll carry with you not just the science of dancing lights, but the deeper recognition that we live in a universe where beauty emerges spontaneously from the intersection of invisible forces. Sleep well, knowing that somewhere above the Arctic Circle, charged particles continue their ancient choreography, painting impossible colors across the darkness, whether anyone watches or not. Sweet dreams.